7 today. We got 1-8 tomorrow. Wednesday we'll kind of do a little review type of a worksheet. And then Thursday we got 1.9. And then no school on Friday. So it's a short week this week. We should have plenty of time today to get some homework done, stamp some homeworks if you got homework for me to stamp, all that fun stuff. We are in the white notes packet. We will start on page 21 in there. Okay. Yeah. We got some, looks like we got 3, I thought there must be a 4th one down here yet too. Yeah, we have 4 problems, including 2 graphs. Love it. Sounds like, how much time? How much time? 5 minutes? 5 minutes? Sure?
Maybe start with that?
Let's start with 5 and then we'll go from there. Yeah, I like that plan. All right. Pitter patter. Common ratio. Okay. That's what we're multiplying by to get the next one. So we can always take any term and divide it by the term right before it. So we could take 36 here and divide it by 12. Or we could take 108 and divide it by 36. Either way, we're going to get that we're multiplying by 3. So R is 3 in that first one. In the second one, 27 divided by 3 is 9. So R is 9 there. Yes? Okay, love it. Each problem below is an arithmetic sequence. That means it's going to be linear. Write the recursive and explicit equations for each sequence, then graph them to make sure the scale in the graph is clearly marked. Okay? So recursive would be the next one. So what are we adding to get the next term? Adding 4. So my recursive equation would be next equals previous plus 4, or f of n equals f of n minus 1 plus 4, if we wrote it in function notation. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. First term is 5, second term is 9, third term is 13, fourth term is 17. So like there's our graph, okay? Like that one. Explicit equation would be, could have it in multiple forms. We could have f of n is equal to 5 plus 4 times the quantity n minus 1. We could have f of n equals 9 plus 4 times, times the quantity n minus 2, so on and so forth. Or we could just simply have f of n equals 4n plus 1. There. One thing we forgot in our recursive was a starting point, or a starting value. F of 1 is equal to 5. Questions on that one? Rachel's grandmother gave her $40 for her birthday. She decided to put her piggy bank and save an additional $5 a week for mowing lawns. Okay, so let's come up with a scale here. Let's go by fives. 5, 10, 20, 30, 35, 40, 50, 60, 70, 80. And that's money. And then she's putting in her money each week. Rachel's grandmother gave her $40 for her birthday. So what week is that Rachel's grandmother gave her $40 for her birthday? What week is that? Week 0, right? Okay. That's week 0. That's where it started. Then after the first week, then she put 5 more in. So my recursive equation is going to be next equals previous plus 5 with f of 0 being 40, or explicit equation. N plus 40, or we could have gone with that one. That one, so on, so forth. Questions on that one? All right. So we just did some arithmetics. What makes an arithmetic an arithmetic? To get what? What makes an arithmetic an arithmetic?
Is addition and subtraction.
To get what?
To the next equals to is plus.
To get the next term then? Is that what you're going to say? To get the next term, we add and subtract? Yeah. Okay, so we add and subtract to get the next term. Okay, we just did 2 examples. We were ready to come up with another example. Okay. What makes a geometric? Yes, ma'am. Multiply or divide to get the next. Okay. So today we got, I think it's like 4 or 5 of them, isn't it? You got 1 on this page. We'll do that one together, and then I think, look, can I flip this over here? And then you got 2 more on the next page, and then you get 2 more. Oh yeah, that's 5. That's 5 total. I love it. Okay, so let's do the first one. So for all 5 of them today, first thing that we have to determine is we have to determine if it is arithmetic, geometric, or neither. Okay? Which means if we don't add and subtract, or we don't multiply or divide to get the next term, that's a neither type of a case. If there's some other pattern, that's neither. Okay? So that's number 1. Okay? Then, number 2, we got to find a recursive equation for it. And number 3, we got to find an explicit equation for it. Okay? All right, here we go. Function A. There it is. Love it. Okay? So first thing, if this were me, okay, if this were me, I would say, all right, this gap here is plus 12. Do we agree with that? I always check arithmetic first because adding is a little bit easier than trying to figure out what we multiply by. Okay, so plus 12 there, which means then this next gap here would have to be plus 12. Is it? Yep. Then this next gap here would have to be plus 12. Is it? Yep. Then this next gap here would have to be plus 12. Is it?
Yes.
Yes. So that means that we're adding 12 every single time, right? Is that arithmetic, geometric, or neither? That's arithmetic. So right off the start, this one is arithmetic. Okay. Common difference then, because arithmetics have common differences. Common difference then would be what? 12. We're adding 12 every single time. Okay? Which means then that my recursive equation is going to be next equals previous plus 12, and we had our first term at 3, or we had our second term at 15, or we had our third term at 27, or we had our fourth term at 39, or we had our fifth term at 51. Got to put down one of those. Okay. If I wanted that in function notation, we could write it like that. Okay. Our explicit equation then I'll take this one. Okay, so then that's going to be my output plus my common difference times n minus my input. Or we could take this one. Both of those simplify down to a much nicer function, 12n minus 9. Okay? Because if I add by 12 to go down my chart, I can subtract 12 to go up the chart, and my 0th term, that gets me that y-intercept, would be 3 minus 12, which would be negative 9. Okay? It's just that simple. Okay? Right? That's what you got to do in every single one of the next 4. So you and your tables now, I'll give you 8 minutes. I like 8 minutes. 8 minutes to go through the next 4 examples. There's 2 on each of the next 2 pages. So first check, I always check to see if we're adding. So if I added 5 here, then did I add 5 there? No, so that means it's not arithmetic. Okay? Alright, so then I gotta check, okay, well, 5 times 2 is 10. Is 10 times 2 20? Yep, is 20 times 2 40? Yep, it is. And then 40 times 2 would be 80 if we wanted to go that far. Right? Alright? So that means it is a geometric. The recursive equation would be the next is equal to 2 times the previous, or f of n equals twice f of n minus 1. And in both cases, we started at 5 with me. Alright? Alright? Our function, our explicit function, f of n, is going to be, we started at 5. We're multiplying by 2. That's going to be to the n minus 1 power if we use that first term. If we use that second term, f of n is going to be 10 times 2 to the n minus 2 power. If we use the third term, it would be 20 times 2 to the n minus 3 power. If we use the fourth term, it would be 40 times 2 to the n minus 4 power. So on and so forth. Yeah? First one that I have written is usually the one that's the smallest number, so that's usually the best one to use. Questions on function b?
Does it matter if you have alternate, just use the multiply sign?
I prefer dots, because once we get into more algebra, the time sign looks like the letter X.
Like the little dot?
Like this dot right here.
Yeah. I was asking if I could use that.
Yeah.
Okay.
Yeah, that's right. Yeah. Okay, good. All right. Function C. First check. Minus 9. Agree with me on that? Minus 9. Minus 9. Minus 9. Minus 9. Yeah, yeah. Is that arithmetic or geometric? It's arithmetic because we're always subtracting 9 each time. So our next is going to equal our previous minus 9, and we started at negative 8. Explicit equation would be f of n equals negative 8 minus 9 times the quantity n minus 1, or we'll go to the last one, negative 53 minus 9 times the quantity n minus 6, or really what I'd really like, negative 9n plus 1. Okay. Good. D, function D, checking do I even, just quick glance at it, do I even need to check addition? Because it jumps from 6 to 18, right? Okay. So that big of a jump without having a big jump at the beginning, don't even need to check addition. But if I were to be checking addition, here it was plus 4, here it was plus 12, right there, arithmetic, gone. Checking multiplication, times 3, times 3, times 3, times 3, times 3, yes? Yep, that one works out, so that's geometric. Oops. Multiplying by 3, so we'll go with the first one. F of n is going to equal 2 times 3 to the n minus 1 power, or 6 times 3 to the n minus 2 power, or 18 times 3 to the n minus 3 power, or 54 times 3 to the n minus 4 power, or 162 times 3 to the n minus 5 power, so on and so forth. Okay? Good to go on that one. Love it. Add 1. Add 3. Add 5. So, nah, right? No. Okay. Multiply by 4/3. Multiply by 7/4. So that's not geometric either, right? So if it's not arithmetic or if it's not geometric, then it's neither. Okay? So the recursive equation, what are we doing to get the next term? What are you doing to get the next term?
Adding 2 to the previous number, like what you're adding to it. 5 plus 2 equals the next number. What you add to 12 to get 19. I don't know how that makes sense, but it makes sense in my brain.
I get it. I understand it. I'm just trying to think of how we could say it nice and cleaner. You know what I mean?
Yeah.
So like the next is equal to the previous plus the next odd number, right? Because it went 1, 3, 5, 7, something like that. Can we find an explicit equation for a neither case? No, you can't. You can next year in math too. We'll be able to figure that one out. Okay. But for right now,
So do we just toss it out?
you just don't fill it in. Okay. All right. So that leaves you an entire mod to be working on the 1.7 homework in the yellow packet. Okay. Let's take a quick little preview of it. We'll walk down what it is. Is this it?
That's 1.6.
I know, that's why I was just making sure. Okay. I didn't think this was it. But yeah, this is 1.6. Oh, there it is. There it is. Now I see it. Okay. So it looks like we're using a table to find some values. We've done that before. We're filling in a table. We can handle that. Common ratio of each geometric sequence. Yeah, we know how to do that. Okay. Filling in the blanks. Making a table. Okay. Which type of sequence is it? Arithmetic, geometric, or neither. Okay. Making a graph of it. Love it. We can handle all of that. Okay. 2 of those, like that. 2 or more points on the graph fit the sequence. Oh yeah. So basically in number 8 and 9, they're, instead of giving you a table for the values of the in the sequence, they're giving you a graph with points on there. So you have to get the points off of the graph like that. And love it. Love it.